Good day, grade 11s. Today's topic is going to be called General Solutions. General Solutions is your old grade 10 content where you had to solve for theta in the first quadrant. Let me just do a quick recap of what you did in grade 10 before I go on to the grade 11 content. In grade 10, the question said solve for theta, and you would have had 2 sine of theta minus 10 equals to 1. And we said to you that theta lies between 0 and 90. You were restricted in that quadrant in grade 10, but not in grade 11. So you know what the rules are. Our goal is to get to theta, but we must obey the rules of getting to theta. Your first step is to get rid of your coefficient, just like it is in algebra. So you would divide both sides by 2. So you would land up with sine of theta minus 10 equals to a half. Now the mistakes that many of you made in grade 10 was you all divided by sine theta or just sin. You're never allowed to do that at all in trigonometry. When you take sin away from its angle, it goes across as arc sine. So what you're basically doing is you're saying when I cross sin the equal sign, it changes its name into arc sine. This name is called arc sine. And on your calculator, you know, you press it by saying shift sine, and you will see the calculator denotation. So when you do that on the calculator, you will say arc sin of a half, and you will land up with 30 degrees. So theta minus 10 equals to 30 degrees. Take the 10 across, and you will land up with 40 degrees. And all what you had to check was, does your angle lie in that quadrant, which was the case. So that was grade 10. Grade 10, we were only interested in one specific answer. Now welcome to grade 11. And it's linked to general solutions. In other words, this is not the only answer that when I substitute back into the original question will give me an answer of a half. There are many answers for theta, not just one. So we are now broadening our scope by working under the heading of a general solution. So under the heading of a general solution, we are going to learn the following types. Type 1 is the basic one. It's the one that we did now, but with a k involved. Type 2 is a name change, where the angles are the same, and the only two functions you'll be working in a type 2 is a sine and cosine. Type 3 is also only sine and cosine, but the angles are different. The type 4 type is called factorization, and the type 5 is where we introduce identities into the sum. There are many methods floating in to solve for theta, but the type that I use, I do not use the reference angle method. I use the set formulas for sine, cos, and tan. So in other words, no matter whether an angle is positive or negative, I will always do sine in the first and second quadrant. My answers can be negative, whereas people who do the reference angle method cannot have negative answers as their reference angle. Cos, I also work in the first and fourth quadrant, and tan, I only work in the first quadrant. Now the plus 360k just implies the period of a sine and cosine graph, just like 180 implies the period of a tan graph. K element of integers just implies that when I'm trying to find specific answers, I'm going to substitute integers in the place of k. Let's start with the basic type. I will post this summary as part of the worksheet. But let's look at a typical example. This is considered to be a type 1. And I know it's a type 1 because theta is only attached to one function called cos. That, although it's called a function, the angle has a specific value. So this is considered an expression. This is considered to be a function. And the only function in this question is cos attached to theta. Now, using your calculator. As I said, this is an expression, so you do not arc sine it. You just put into your calculator sine 30, and you will get a half as your answer. And remember, just like grade 10, your goal is to get to theta. So you've got to divide both sides by 3. So back to your calculator, don't remove your answers. Divide by 3 and you'll end up with negative 1 over 6. Leave it as a fraction. A fraction is always more accurate than a decimal. Now I'm going to take cos to the other side. So when cos crosses the equal sign, I'm left with 2 theta plus 10. It becomes the arc cos of negative 1 over 6. Okay, so straight away I'm working in my first quadrant. Remember, the minute I introduce this, I've got to introduce the period of that graph, which is 360k. The people who do reference angle, you people will call this reference angle. You will remove the negative sign because your reference angle is only positive. As I repeat, this is the method that I'm using to solve for theta. So based on this answer, I landed up with 2 theta plus 10 equals to 99,594,06823. Do not round off your answers. It is only rounding off at the end. I then take the 10 across, so I subtract 10, and then I divide by 2. But let me not do that all together. So 2 theta equals 89,594,06823. And then when I divide by 2, it affects everything, even affects the period. So if I divide by 2, I will land up with 44,80 plus 180k. Okay, now I've done the first quadrant. I'm now going to move on to the fourth quadrant. The reason I pick first and fourth is because I'm working with a function called cos. So here you will have 2 theta plus 10 equals to 360 minus the arc cos of negative 1 over 6 plus 360k. So in other words, you always go back to the beginning when you decide to take cos across. I put this into the calculator as is. 360 minus the arc cos of negative 1 over 6. And I land up with 260.4059318. I then minus 10. And then I divide by 2. You will notice that I only round off at the end. And only once do I need to write k element of z. Okay, so these are the general solutions for that sum. That means there are many answers that will give me an answer of negative a half. Now, part B says I want specific answers where the angles only lie between negative 90 and 90. So what I will do is I will take my first general solution, which is 44.8 plus 180, and in the place of k, I'm going to substitute 0. And I land up with 44.8. But that's obvious because that would become 0. And 44.8 does fall in that range. If I backspace the calculator and I substitute 1 in there, I land up with 224, which is out of my domain. If I backspace and I put negative 1, I land up with negative 135.2, which is outside of this. So I can get no more answers from this. I then move on to my second general solution. So I've got 125.2 plus 180 times 0, will just be that answer, 125.2. If I backspace and I replace it with negative 1, I land up with negative 54.8. So in this general solution, negative 54.8 does fall in that domain. If I try and substitute minus 2 in here, it will be too small. And if I try and substitute positive 1 in there, it will be too big. So this is my only two solutions to that sum. Okay, this is the basic general solution type. Grade 11, I'm going to end it. I will do type 2 tomorrow.